These two questions were remaining, so now we're going to do this. Okay, so the first question is the limit as x approaches 0 of 2x to the power of 3 power x, 2x to the power of 3x, sorry. So we can write this as e to the 2x, e to the 3x natural log 2x, right? And this is obviously the limit as x tends to 0. Okay, and now if we can find what this limit is going to be, we are done, right? So first of all, we need to find what limit as x approaches 0 of 3x natural log 2x is going to be. So we can write this as natural log 2x upon 3x, right? And this is like limit x tends to 0. So this thing is now a negative infinity upon infinity situation. In fact, let's just write it like this: negative, let it be, just write it like this, it will be sufficient, right? So now this is some kind of negative infinity upon infinity situation. So the next thing which we want to do is take a derivative. So limit x tends to 0 using the L'Hopital's rule, I don't know, whatever that thing is. So the derivative of natural log 2x, that thing is 1 upon 2x times 2. So this is going to be 1 upon x, right? Upon derivative of 3x is, this should be 1 upon 3x. That's much better, because this thing approaches infinity and natural log 0 is going to negative infinity. So this is going to be a negative infinity upon infinity situation. So the derivative of 1 upon 3x, that thing is negative 1 upon okay, just say negative 1 by 3, and the derivative like 1 by x, so it's negative 1 upon x squared. Correct? Yes, that's perfectly correct. So this should be negative x upon 3, right? So this thing, limit as x tends to 0 of e to the 3x natural log 2x, that's going to be e to the limit x tends to 0. And yeah, just put 0 into this thing, this is going to be 0, right? So 3x natural log 2x, and now we know that this limit is going to be 0, so this thing is just e to the 0, so this should be 1. So this limit is 1. Next question. So this is another question which I could not do, and now I realize there's kind of a general method for doing these kind of questions. So for any question which is of the format 1 to the power of 1, where these ones are not solid ones, they are like something which is approaching 1, right? So for these kind of questions, we have this very general method. So just say that 1 minus cosine of x upon m, that thing is u. So we can write this thing as 1 minus u, 1 minus u to the power of m, right? So the limit as m tends to infinity of this thing, this is L. Okay, nice. So you can see that u tends to 0 over here. So if we take 1 upon L, then this should be okay. In fact, let's just take 1 upon L in the very start itself, right? That will be a better choice. So yeah, suppose what we need to find is limit L, then 1 upon L is the limit as m tends to infinity of sec x upon m to the power of m. Yes, and now we can say sec x upon m minus 1 is u. So this thing is literally just limit m approaches infinity, and substitute this in form of u over there. So this should be u plus 1 to the power of m. So this thing is limit m approaches infinity, u approaches 0 of 1 plus u to the power of 1 upon u to the power of m times u, right? So this thing is going to be e to the limit as m approaches infinity, u approaches 0 of m times u, because if this limit exists, and this we know is obviously going to approach e, and this is going to approach some other number, so in effect these things, like this complete expression is going to approach e to that number, correct? So this is going to be e limit m approaches infinity, and over here m was secant x upon m minus 1, right? Sorry, that was u. Okay, so m into secant x upon m minus 1. So now we just need to find what this limit is going to be, which now does not seem that bad as compared to the other thing, right? So secant x upon m, m approaches infinity. So this is like an infinity into 0 situation. Guess what, we can do the same thing that we did in this question and write this as sec x upon m minus 1 upon 1 upon m. So now this is a 0 by 0 situation, and then we can take a derivative. Nice. So the derivative of this thing is okay, sec x tan x, right? So sec x upon m tan x upon m. The derivative of the inside stuff, that thing is, okay, x is a constant, then derivative of 1 upon m is negative 1 upon m squared, derivative of m is 1, okay, upon derivative of 1 upon m, which is negative 1 upon m squared. So this cancels, so we just get now we just have to put m equals to infinity into this thing. So putting infinity into this particular thing, we are going to get 0. So this is just going to be 0. That was easy. So this is just e to the 0, which is 1. So this limit is also 1. Nice. So that's it. I will see you in the next video.